Last session we discussed about the interconnection about the different functional components. In that basically the computer has the different components that we have seen, the input, output and the CPU, how exactly the interconnection happened between the different components. Basically we have discussed three different buses: address bus, control bus and even the data bus, right. So basically in the address bus it will carry only the address of the memory location, and the data it will just based on only the data it will just it will carry, and the control basically entire control of the different components will be taken care by the control bus. So this is what we have discussed in the last session. Today in this session we will continue with respect to the topic microprocessor. First we will try to understand what exactly the microprocessor is and how exactly it works, and what are the different classifications when it comes to the microprocessors. We will go one by one. First microprocessor. Again, microprocessor is a controlling unit. We can say the controlling unit of a computer, right. So how we know the importance of the control unit. Overall the coordination, overall the data control will be happening through the control unit, right. The same will be taken care by the microprocessor, so that we call it as a microprocessor is a controlling unit of a computer. And basically that how exactly it has been built in the system, it is we also call it as a small chip, even we can say ICs, integrated chips. So that chip will be in the position to perform all our calculations with respect to the ALU, that is arithmetic logic unit operations, and also it will take care of communicating with other devices which is connected to the CPU. So basically we have connected input and output devices to the processor. So along with the operations of ALU operations, it will also take care of communication or communicating the things between the different devices which are connected to it. And next, also microprocessor, already we have discussed in the first point, it consists of the ALU, register array and a control unit. The intention of microprocessor, basically the job is controlling unit, right. In the same way the microprocessor also it consists of ALU, because it need to perform all the arithmetic logic operations, and register array, as we have discussed in the last session, it is a kind of temporary storage, and along with some of the registers it will be acting as a temporary storage device, and also a control unit to control the entire flow between the different components. And the job of the ALU that we have seen already, ALU performs arithmetic and logical operations on the data which it is received from the memory, or maybe directly you may receive from the input devices. Sometimes which is already available in the, that is nothing but it is a stored data. Whenever we do some arithmetic logic operations, maybe we are getting from the data which is already stored. So either you can take it from the memory, or maybe you can directly take it or you can receive the input device. And register array, as we have discussed in this point, register array, basically that register array it will consist of different registers. So basically which are identified by the alphabets, like the letters B, C, D, E, H, L and the accumulator. These are the some of the very important registers which will be identified, these letters. And the job of the control unit is the flow, it controls the flow of data, not only the data, even it also controls the instructions within the computer which we have used. This is a typical block diagram of the basic microprocessor. So in the same block diagram you can just we can see this is an input device, output device, this is a processor, CPU, right. Now we are talking microprocessor is a part, like within the processor, what we can say the CPU. So that is microprocessor. This microprocessor is now in between input output, and basically this microprocessor consists of, as we have discussed in the last slide, this will consist of ALU, register array and then the control unit. Just combining all these three, that will be depicted in this block diagram: ALU, register array and then the control unit. We have seen in the same last slide what is the role of ALU and register array, how exactly it was defined the register array and the job of the control unit. And this will be coordinating, or whenever in the previous slide we have discussed the points, right? What is that? Data received from the memory. So how exactly it will receive? See, it is like bidirectional. Whenever you want to store the data into the memory, yes, you can send it to the memory. So whenever you want to fetch the data from the memory to perform something, ALU operations or any other operations, it's again you can go and get that data from the memory and perform. Then you just send through the output device. This is what the typical that black diagram, which is almost similar to the basic components of the computer in the first concept what we have discussed. The same diagram, just here in this we are talking about the microprocessor. It's kind of bit we are just that CPU instead of CPU, because CPU consists of all these things, but now we are talking about only the microprocessor. That is the reason in the place of CPU I have mentioned a microprocessor, and what exactly the microprocessor consists. All together it will be in the form of chip. So that chip will be acting as our microprocessor, and it will perform all the activities that we have mentioned in this slide and the previous slide. Now we will try to understand through this. We have seen the diagram, block diagram, and also the major components which microprocessor consists, right. Now we will try to understand how exactly the microprocessor works. So basically the microprocessor follows this sequence. What are those sequence? Fetch, decode, and then it will execute. So these are the this is how it sequentially it is trying to proceed further. Like fetch is the major step. First one, it's there's a sequentially it will work. Fetch is the first one, and then decode it, and then finally you execute. By considering these sequence, microprocessor will start working. Now we will see initially how it works. The instructions, whatever we are sending, instructions are nothing but a set of instructions, are nothing but the programs, right. So those instructions are stored in the memory. Whatever the instructions you have given, that will be stored in the memory. How it will be stored? In a sequential order. Sequence that we have seen already, sequential and non-sequential. Sequential is nothing but it's one after the another, like what we have discussed in the last session. It is like example page, one page after the another page. In the same way, the data or the instructions which you are sending, that will be stored in the memory one after the other. In what manner? Maybe with respect to the memory address, or with respect to the location where exactly the data, the instruction want to store. So that will be stored in a sequential manner. That is nothing but one after the other. Next, once that storing part is over, next microprocessor fetches. Now the fetch will come into the picture, because already it is available in the memory, the instructions are stored in the memory. Now microprocessor, what it will do? It fetches those instructions, whatever the instructions you have stored already in the memory, that will be fetched, fetches those instructions from the memory. Then it will start decoding it, because it has to understand, because whatever the instructions you have given, that has to be maybe that is because that's in the high level language, that has to decode it, what exactly, what instructions you have given, how exactly I need to process, what work or what task I need to accomplish. So all those will be first it will be fetched, and then it will start decoding those instructions and then execute those instructions. Yes, I have decoded the instructions which you have given. Yes, maybe if I assume if I want to print something, print is the instruction. So that is in the high level language. What happens? It will try to decode exactly what I want to do and what exactly you want to print. So that is a job, because print, yes, maybe it will understand in one. I am just talking about with respect to the one programming language. Maybe if you go in in very basic level, it's another, any instructions. If I say A plus B, or maybe I think in the next session we will try to discuss how exactly the CPU works. CPU work means maybe that CPU consists of this one, right. So the same way We will try to understand through that example how exactly it works instruction by instruction. So, that we will discuss in the next session, but we will try to understand. So, whatever any instructions, maybe addition or subtraction or printing something, or maybe you are calculating something, or maybe you are just playing something, any task. So, that will be stored in the memory, and whenever you want to execute that, that will start fetching all those instructions from the memory. Once it starts fetching, then it will try to decode. That the purpose of decoding is just machine has to understand what instructions you have given. So, after that decoding, then it will be start executing those instructions. How long? How long it will execute all those instructions? Till you need to pass, or till it continues the stop instruction. Once it finds or found the stop instruction, then it will stop its execution. That means stop is must. Based on that instruction, it will stop its execution. So, this is how it executes. And later, how after the execution, yes, decoding has been done, and then execution has been done, reach the stop. Once it found the stop, it stopped, and then later it sends the result binary to the output, because yes, initially it has taken 20 or 10, whatever the value. If I am talking about the addition of two numbers, whatever the number you have given, that will be stored in the memory. 10 will be converted into the, that is nothing but decoded into the respective manner, because system, as we have discussed in the classification, your computer will understand only the digits, like zeros and 1 binary digits. So, now the 10 or 20 or A or B, whatever you give, everything will be decoded. As per that conversion, it will execute that. Now, after execution, again that will send the same result, whatever the task or the computation the processor has been done, the result, once it gets the result will also be in the binary, right. So, that will send the results in binary to the output port. It is not at output device, it is just it will send that result to the output port. So, between these processes, the registers, what exactly it will do? It will stores the temporary data, because in the last slide itself we have mentioned microprocessor consists of ALU, register, and then the CPU. Registers, basically there we have discussed, register will allow you to store the data temporarily. It is not permanent storage, it is temporarily it will store that data, and it performs all your nothing but ALU will perform all the other computing functionalities or the functions which you want to perform. Now, so basically what are the important terms which we use in the microprocessor? So, here we have given some list of the items or the terms which we use very commonly or frequently whenever we talk about the microprocessor. These are the terms which we use very commonly. One is instruction set. That is what we have seen, right? Instruction will be stored in the memory in the previous slide. Now, there is a common instructions. Second one is the bandwidth, and then the clock speed. First, we will try to understand, and even a few more terms, word length, and then the data types. So, these are the some of the typical terms, or very commonly these terms we are using whenever we talk about microprocessor. We will try to understand one by one. So, what is instruction set? Last time, the last session we have discussed it, right? Last slide, instructions, the last slide. So, it will send the instructions. So, a set of instructions that the microprocessor can understand. Whatever you send, whatever you in the sense, whatever the as a user will send. So, that will be decoded, that we have seen in the last slide, because microprocessor has to understand, right. So, that we call it, all those set of instructions, we call it as a instruction set. Next, bandwidth. So, whenever we are talking about the internet, right, it is a bandwidth. What is the bandwidth? So that means number of bits, it is actually number of bits processed in a single instruction. If you take one instruction, or if you talk about one instructions, how many bits, you know what is the bit, right? It's either 0 or 1. So that how many bits, number of bits will be processed in a single instructions. So that is talking about bandwidth. Always we use that term, because when the bandwidth is per second, if we talk about, because there are so many instructions whenever you want to write something, or whenever you want to perform or develop an application. So obviously that application has a lot of instructions, and now the speed of that application determines how many instructions, nothing but how many operations, number of operations will execute in 1 second. So that is nothing but the clock speed. It will determine the number of operations per second the processor can perform. So usually we talk about, whenever we talk about the cell phone, whenever you want to buy a cell phone or a system, we talk about what is the processor, or the speed of the or the processor size, right? It depends, because how quickly the system or the device will perform your instructions, right, or nothing but the operations. Because as an end user we talk about only the operations, but as a programmer we talk about the instructions, right. So always this clock speed will be measured or expressed in the megahertz. Now most of the systems are in gigahertz. Also we call it as clock rate. Rate of how quickly that will perform, that will be measured by the speed or nothing but the clock rate. Next, length, word length. It depends upon the width of the internal data bus. As we have seen in the last session, there will be a during the discussion of the how exactly it will be interconnected, the different components, that majorly it consists of data bus, address bus, and then one more is the or we call it a system bus, or nothing but the system bus, right. So basically this data is carrying the data bus will carrying the data, and even what is that address will carry the address, right. Similarly now we will try to understand word length. It depends upon the internal data bus, how much data with respect to in each internally how much data it contains in that bus. And also registers. Register, as we have seen, registers are, it's a temporary storage, and ALU it performs all the arithmetic logic operations, and many more even control unit all. So basically the length of the word when you want to perform or when you want to execute something, so it always depends on all these things. So how much data you have, and what are the different registers you have used to store the data temporarily, and what are the different calculations or nothing but the computations you want to do. Because if you talk about just a plus b, what is this? It's just a simple expression. It consists of two variables, one is a and b, and this one addition, one operation. So now in this data is a and b, data internal data bus, but bus carries only these two, a and b. And ALU, what is the use of ALU? It performs arithmetic operation, that is a plus. And now the register, it will store the temporally, it will, of course it will store it in the memory, but whenever it wants to perform the arithmetic operation, it has to fetch from the memory, temporarily it has to store that a and b value. So ALU will start performing adding these two numbers. So now this is very simple instruction. Assume the same a plus b into c. Now it has more number of instructions. A, data is a, b, and then c, and then we have addition operator, then multiplication operator, then also we have a parenthesis. Data, what exactly it carries all these things, and now it increases the data. Earlier we have only 1, 2, and then one arithmetic operator, but here now 1, 2, 3, 4, 5, and then the braces, we are defining which expression you need to evaluate first. Now the data is increasing, and even the operations, first ALU, first it will add, and then it will return the result that will be stored in the temporary memory, and then after that whatever the output of this, that will be multiplied with this variable. Now the cycles of executions will be more. Obviously when the cycles are increasing, even the internal data, the data bus which carries the data, even that also it increases. So it all depends on, by considering all these things, we call it as a word length. The length of the word is less here, but here it is more, because it consists of more number of variable and even the operators, all these things. Right. So now an 8-bit microprocessor. So just there are typically we have a different size of the microprocessor. When we talk about 8-bit microprocessor, it will process only 8-bit data at a time, because my capacity is only 8-bit. So I cannot process more than that. So even maybe I think whenever you buy a system, it's a 8-bit processor or 32-bit or 16 or 64. Now most of the machines which we use generally as a personal use, it is like 64-bit, right? Now that's what, if it is 8-bit, it will process only 8-bit data at a time. If it is 16, it will process 16-bit data at a time. If it is 32, yes, it is the maximum limit. So at a time it will process only those many bits, depending upon the type of the computer. If you are using 8-bit computer, it will process only 8-bit data. If you are using 32-bit of computer, it will process 32-bit data. Similarly 64. It all depends on the which type of computer you are using. And then another one is type of the data. That is also very important, right? What type of, because everything in the computer, we it depends on the type, what type of data you are going to process, right? So the microprocessor, of course, it has multiple data type formats. Those are like binary or maybe BCD and even the ASCII, signed and unsigned numbers. So these are the different formats, data type formats which we use in the microprocessor. Based on that data type format, it will start processing the instructions. Now we will try to understand the features by considering by just recalling all the concepts what we have discussed. We have seen that block diagram, what exactly the microprocessor consists, and what are the different the working principle behind this microprocessor, how exactly it works, and we have seen the word and the clock rate or the bandwidth, everything, right? By considering all these things, we will try to understand the processors of the we can say the features of the microprocessor. Cost effective, because it's very important, right? Whenever we want to talk about microcomputer or mini computer, cost also matters. So it's a cost effective. How do you say it's a cost effective? Because microprocessor chips which are available at very low cost or low price. So obviously when your chip or microprocessors are available in less cost, obviously even the whole system will be available with less cost. And when you talk about the size, obviously it's very small size chip, hence even you can port, because size is very small. And the low power consumptions, because microprocessors are manufactured by using, see this is very important, by using metal oxide semiconductor technology. So based on this technology, metal oxide semiconductor technology, based on this technology microprocessors were manufactured. So obviously whatever whichever it is manufactured based on this technology, it consumes very less power. Right, that is the reason it is also one of the major feature when we talk about microprocessor, low power consumptions. Versatility. So versatility is nothing but microprocessor are versatile, as we can use the same chip in a number of application by configuring the software program. Whichever the software you want, you can configure in your system. Automatically your microprocessor will be will do that, or will be the same chip, whatever the microprocessor chip you have used in your used, the same chip now it will be used in the number of applications, whichever the applications you have configured in your configured. And reliability, that is very important, right? Whatever you use or whatever we perform, it is very important. Reliability, can I reliable, or is it reliable or not? So the failure rate of this integrated chip in a microprocessor, the failure rate of an IC in a microprocessor is very low, hence it is reliable. That already I think in one of the previous sessions we have discussed, that also very low. We are talking about failure rate is very low. That failure rate always, again, it depends on the data which you send. Based on that data, even the failure rate. So that is the reason it will be very less, or we can say the very low error, or we can say the failure rate. Hence we can obviously we can rely on it. So now we will talk about the classification. So these are the major classifications of this microprocessor. One is all the processors are built either RISC processor or CISC or special processor. We will talk about only the RISC and CISC. What exactly the RISC is? It is a reduced instruction set computer. Even the same thing we can use it in the microcontrollers also. As we have discussed microprocessor, there is another concept called microcontroller. There also we use the same RISC and CISC. So now we will try to understand RISC processor, as the name itself, RISC, reduced instruction computer, reduced instruction set computer. Basically it is designed, the name itself says reduced. The purpose, or this is how this is how it's designed. It is designed to reduce the execution time. To reduce this execution time, how do you reduce the execution time? By simplifying the instruction set of the computer. If your instruction set is not so simple, then obviously your execution time will be more. So the purpose of the purpose here is we need to reduce the instruction set. So once you reduce the instruction set, obviously your execution speed, or the time will also improves. So that is based on that concept. It is designed to reduce the execution time. How do you reduce? By simplifying the instruction set of the computer. Using RISC processors, each instruction requires only one clock cycle to execute results in uniform execution time. Try to understand. Each instruction, you take any number of instruction, but every instruction, it will require one clock cycle for what? To execute whatever you want to execute the results in the uniform execution speeds, like it will be common execution time. And also this reduces the efficiency, as there are more lines of code, hence more RAM is needed to store the instruction. Random access memory we have discussed, right? So basically what happens, it will try, it is trying to reduce the nothing but what we can say, it will whatever the RISC instruction set, nothing but reduced instruction set here we have used, that reduces the efficiency, as there are so many lines of code. Obviously once we have more lines of code, even the RAM size also it requires more. And compiler also has to work more, obviously, right? If I have only 10 lines of code, it will start compiling quickly those 10 lines, because all the 10 lines will be compiled at one time, and then it will be converted all 10 lines at one shot. Now if I have 100 lines of code, because more lines of code, so obviously if you have more lines of code, even the compiler job also it increases, because it has to convert. Compiler job is what? It converts from one language to the another language. Basically whatever you write, everything will be in the high level language, that has to be converted into the machine language or machine code. So now when the code size or the line of code increases, obviously your compiler will also has to work more, because it has to translate all those lines from high level to the machine level code. So, obviously the compiler work will be more. And characteristics, we will try to understand the different characteristics of RISC. Major characteristics of this reduced instruction set computer are as follows. It consists of simple instructions and varieties of data type, because already we have discussed in the microprocessor. Microprocessor itself supports so many different types of data formats, right. Obviously RISC also supports various data type formats, and also it utilizes simple addressing mode and fixed length instructions. We discussed about the word length, right. So here the same even in this RISC it will utilizes the addressing mode, whatever the addresses which will use, that will be simple addressing modes, and also a fixed length. It won't vary. If I say 5, it will be like kind of fixed length. There is no change in the length of the instructions for pipelining, because it has to execute, right. So and then it supports the registers to use in any context. Whenever in any context you can use the make use of the register support. And always you remember this one cycle execution time, because in the previous one of the feature we discussed, right, only one clock cycle to execute the results, only one clock cycle. So obviously what happens, one cycle execution time. And what are the important instructions are used to access the memory location? One is load, another one is store. So whatever you want to store into the memory, you can use the instruction called store. So which is already stored, the data I want to get it. So I am trying to load that data. So basically these are the two important instructions, load and store instructions we are using, or are used for what? To access the memory location. And obviously it consists of large number of registers, it consists of very less number of transistors. These are the some simple characteristics with respect to the RISC. Now another classification is CISC. It is a complex, one is reduced, and here is the complex instruction set computer. How it is it has been designed? It is designed to minimize the number of instructions. There it is trying reduced RISC, and now we will try to compare that with CISC, this with RISC. Here the CISC is designed to minimize the number of instructions per program. We are ignoring the number of cycles. In the RISC there is only one cycle, execution is one cycle, right. That is what we have seen, one cycle execution time. So now instead of focusing on number of cycles, you here focus is to minimize the number of instructions per program, to receive the minimize the number of instruction per program. So here ignoring the number of cycles per instruction. To emphasize is on building the complex instructions directly into the hardware. So make use of the hardware, and directly you can just use the, or you build the complex instruction into the hardware itself. So obviously the compiler has to do little work to translate high level language into the assembly level language, because most of the complex instructions which are directly into the hardware, now the compiler work is very little work, because most of the instructions already part of your hardware, right. Now it will be translating whatever the rest of the instructions which are there for execution, that will be translated from high level language into the assembly level language, or it may be the machine level code, because the length of code obviously it reduces. In the RISC there will be a more number of lines, number of lines. Obviously the compiler work will be more, but here most of the instructions will be directly into the hardware. So obviously there will be a little work to translate from one language to the another language. So obviously here also when you compare to the RISC RAM is more, here little RAM is enough to store the instructions. So with respect to this, we will try to understand the characteristics, variety of addressing modes, and larger number of instructions because we need to reduce the number of instructions. So, obviously, we need to have larger number, and the format of the instruction is length of the instruction format is variable by nature. That means it keeps changing, and then in the RISC there will be a one cycle execution time, but here there will be a several cycles may be required to execute one instruction. So, there one, here it is a several instructions or cycles it required to execute one instruction. And instruction decoding, this is the complex part in this CISC, and one instruction is required to support the multiple addressing modes. You need one instruction which is required to support for the multiple addressing modes.